Okay, so we moved on to chapter 5. So, chapter 5 is about aqueous solutions, and starting off here with concentration. So, concentration means amount per volume. So, like if you go to the grocery store, you can buy orange juice concentrate, and what orange juice concentrate means you have all the orange juice goodness in that plug of orange juice that you would have an entire pitcher of orange juice. So, orange juice concentrate. So it just means more stuff for a given volume. And we use a couple different types of concentration terms in chemistry class. Usually we use something called molarity. So in a 1 molar solution is 1 mole per liter of solution. So for instance, 1 molar hydrochloric acid HCl solution, you take 1 mole, which is 36.45 grams of hydrochloric acid, and dissolve it into the total volume of 1 liter of water, and that is a 1 molar solution. So we can do these for some of these problems. So what is the molarity of a solution containing 25.5 grams of potassium bromide to make 1.75 liters of solution? So the way you do this, dimensional analysis, 25.5 grams of potassium bromide, and then you have moles KBr, and the molecular mass of KBr is 119 grams KBr, and then leave blank 1.75 liters. And if you calculate this out, you get 0.122 moles KBr per liter, or 122 molar KBr, like that. So same units like that. So recap, this one is pretty straightforward. You have mass, convert to moles, and then divide by the volume to get the moles per liter. So next problem here, to what volume should you dilute a 0.2 liter of a 15 molar sodium hydroxide solution to contain 3 molar sodium hydroxide? So this is using the M1V1 equals M2V2 is a dilution problem. You can solve for that, and you want to know what volume should you dilute it to. So this is the equation: molarity of 1, volume of 1 equals molarity of 2, volume 2, which is moles equals moles. So, and you want volume, so it's just going to be V1 or V2 is going to be, I'm just going to keep 2 V2 over M1. So let's see here, you want a 3 molar, so it's going to be 15 times 0.2 all over 3, like so, because we want that. So it's just going to be 5 times 0.2, or 1 liter. So you need to, that means the total volume needs to be 1 liter, or you add 800 milliliters, like so. So, and it, just so you know, the explicit thing here, this M1, this is going to be 3 liters. This is our unknown. This is going to be 15, and this one is going to be 0.2. And I should do it with 3 sig figs, so it should be 1.00 liters. So to have the proper number of sig figs there. Okay, so let's see if you can do this. 50 milliliters of a 0.5 molar solution will make what concentration at 200 milliliters? So let's see if you can solve this one doing the M1V1 equals M2V2. And if you increase the concentration, increase the solution by a factor of 4, you're going to decrease the concentration by a factor of 4. The answer is A. Okay, so let's talk about solutions. A solution is a homogeneous mixture. It's a uniform mixture. Okay, and some things about a solution. What you have the most of, that's known as a solvent, and the solute is the least. So the solvent is what does the dissolving, and the solute is what is dissolved. So for instance, ocean water, depending on where you're at, is about 96.5% water and 3.5% salts. Mostly sodium chloride, but has other salts as well. So with that in mind, the water is a solvent and the salts are the solute. So the salts are dissolved by the water in ocean water. Also, there's a couple types of aqueous solutions: strong electrolyte, weak electrolyte, and non-electrolyte. So a strong electrolyte conducts electricity very well. A weak electrolyte kind of conducts electricity a little bit. Non-electrolyte does not conduct electricity. Pure water is considered a non-electrolyte. It doesn't conduct electricity very well. So my grandmother, well, she's passed away, but she was swimming in a lake one time, a freshwater lake, and it got struck by lightning. And she said she felt a kind of a buzz on her, but she was fine. She obviously didn't die because I would not be here. It was when she was young. So to give you an idea, water, even like in a freshwater lake, does not conduct electricity very well. Where if you put a strong electrolyte in the water, it will conduct very well. So why do things dissolve? So generally speaking, things dissolve because there's more attraction between the solvent and the solute than the solute itself. So water, we haven't learned too much about water yet, but water is a polar molecule, which means that one end of the molecule is negative and the other end is positive. In this case, the oxygen is negative and the hydrogens are positive. And the negative end of the water is attracted to the sodium plus ion, and the positive end of the molecule is attracted to the chloride anion. And here in salt, so sodium chloride salt will dissolve in water, and it forms an octahedral complex around it. So 6 water molecules will surround both the positive and negative parts of it, and that this whole complex then goes and pulls in solution. That's how water is able to dissolve sodium chloride. And the idea is that those 6 interactions, or I guess 12 if you count the 2 ions, is stronger than the attraction they have for each other. And later on we'll talk about solubility rules, and notice with the solubility rules that the soluble compounds are the ones that are really low in charge. And here's sugar. So you can see the big sugar molecules. Those similarly have an attraction to water, and then that pulls it out. There's other things involved in the sugar molecules. Sugar molecules have something what's called hydrogen bonding, and that's when a hydrogen is directly attached to an oxygen, nitrogen, or fluorine in a molecule. And water has hydrogen bonding, and the other molecules, the other atoms in the sugar will do that. So okay, let's talk about the different types of solutions here. So we have a non-electrolyte solution like sugar water, does not conduct electricity. And if you can see the light is a little bit on, and then the light here is really on for a strong electrolyte, and for the non-electrolyte it's not going at all. So weak electrolytes, this looks like it's vinegar. It tends to be molecular. So if you look at these molecules, there's a weak electrolyte. There's a weak acid, a vinegar, and it mostly stays together, but it slightly breaks apart. And you can see here there's only one of them breaks apart. Usually on the upward of 90% or higher of the molecules tend to stay together. Only a really small amount break apart into ions, and then that conduct electricity. Whereas sodium chloride is a strong electrolyte that will break apart very easily, like so. Okay, so which one conducts electricity? We have potassium bromide, an ionic compound. We have 1 molar glucose and 1 molar methanol. Methanol and glucose are both molecules, and they are non-electrolytes, so it is the potassium bromide is the one that's going to conduct electricity. Okay, and I mentioned solubility rules, so let's talk about these a little bit more. And here is a chart, so one of the things you can learn how to read some of these charts. The top ones these are the compounds that are generally soluble. So alkalis and ammonia are always soluble, and this is aqueous. And nitrates and acetates are also always soluble. Chloride, bromide, iodide tend to be soluble with the exception of silver, mercury, and lead. And sulfate tends to be soluble with the exception of the alkaline earths, lead +2, and silver. So this is the general rule. They tend to be soluble with that. Now the following tend to be insoluble. So hydroxide and sulfide tend to be insoluble with the exception of alkalis and ammonia. And sulfide with the alkaline earths are soluble, and hydroxide with the alkaline earths are slightly soluble. They are the hydroxide with alkaline earths are very slightly soluble, like lime water, calcium hydroxide water. You can drink the stuff. It's very, very insoluble. Then carbonate and phosphate, these tend to be insoluble with the exception of the alkalis and ammonia. And notice something. It's the small charges, the +1, -1s. Those are the ones that tend to be soluble, and you get higher. So you get higher up in the carbonate -2, phosphate -3. Then, generally speaking, those compounds are insoluble. And that's the reason why things dissolve, because of the attraction between water and the solvents. I'm sorry, solutes. Okay, so let's see if you can do this. So can see if these are soluble or insoluble. Lead chloride. So chloride here, they tend to be soluble, the exception of lead. So because of this, lead chloride is going to be insoluble. So do you see that? Chlorides tend to be soluble, but lead's an exception to that. So because of that, it is insoluble. Copper chloride. So chlorides tend to be soluble. Copper is not an exception. So copper 2 chloride is in fact soluble. Calcium nitrate. So nitrates up here. So here's a nitrate. Nitrates are soluble, no exceptions. That is soluble. Then the S for soluble. And then D, barium sulfate. Sulfate tends to be soluble, but with the exception of alkaline earths, so strontium +2, barium +2, this is an exception. Therefore, this molecule, well, I shouldn't say a molecule, it's an ionic compound. This compound is insoluble. Okay, let's see. Okay, and what happens when a compound is insoluble? What forms is a precipitation reaction. So here we have potassium iodide and lead nitrate, and then they form this lead iodide precipitate. And excuse the heteronormality of this, I just use this as an easy way to explain things. Look at the metals like the kind of the sticks and the kind of the boyish diagrams, and then the anions as the girls. So the boys will only match with the girls, and the boys won't mix, and the girls won't mix, because I know this is different than real life, but the boys are denoted as positive charges and the girls are denoted as negative charges. So 2 positive charges will not interact, 2 negative charges will interact. Only the positive and negative charges will interact. So when you have an equation like this, when you have potassium iodide and lead nitrate, you have to look to see if the combination will result in an insoluble compound. In this case, you are going to look at, it'll be potassium nitrate or lead iodide. And in this case, lead iodide is in fact insoluble. So let's look at these. Writing equation for precipitation reactions. So 5.6 here, we have potassium carbonate and nickel chloride. So the question is KCl plus NiCO3, that's actually going to be 2 here. So are these going to be soluble or insoluble? So All alkalis are soluble, so this is going to be soluble. And nickel carbonate, carbonates tend to be insoluble with the exception of alkalis and ammonia. And because of that, this is a solid and it will involve a precipitation reaction. And the next one here, sodium nitrate and lithium sulfate. So doing this, I can balance it out. It's going to be Li, 2Li, NO3 plus, more space, plus Na2SO4. So all alkalis are soluble, so these are both aqueous. These do not form any precipitate, and because of this, this is no reaction. I mean, they can mix together, but nothing, you'll look at it like nothing will happen. Whereas the first one, potassium carbonate, nickel chloride, you will see a nickel carbonate precipitate in that. The one, the 5.7, absolutely nothing will happen. And if you're wondering, I'm looking at this chart. Well, I'm not looking at it. I have it more or less memorized. You do not have to memorize this chart. I will provide this chart for you. So you don't have to worry about having to go home and, oh, shoot, I better memorize this now. No, you don't have to memorize it. Okay. Let's see if you can do this. Copper chloride and lead nitrate. Is anything made? So go and look at the previous chart and see if you can figure this out. And if you submit some hints, you need to look at copper nitrate might form, and lead chloride might form. And if you look at the chart, lead chloride is an exception, so lead chloride will form as a precipitate. Copper nitrate, all nitrates are soluble. Cl2NO3, that doesn't exist, that's two anions. Or no reaction is a possibility. Nothing, that's not true. In this case, there is a precipitate. Okay, so join me for the next one.